The broadcast is now starting. All attendees are in listen-only mode.
Okay, good morning or good afternoon, and thank you for taking the time to join us today. My name is Lori Elliott, and I will be your host for today's session. Just before we get started, I've got a couple of housekeeping notes. This presentation is being recorded, and you will get a copy along with any additional resources emailed to you shortly after today's event. The session will run about 30 to 35 minutes, and we'll open it up then to Q&A. So there's two features to the platform that I just want to clarify with you. We've got the chat. This is where you'll find my email address if you have any follow-up questions for today, and just general conversation. If you have questions for today's presenter, please type those into the chat panel, and I will read them at the end. So with that, welcome to Turning Live Tools and Part Handling with Fusion CAM. Today's presenter is our MSD applications expert, Nate Cassou. So Nathan, I'm going to go ahead and hand the floor over to you.
Thank you, Lori. Hello and good morning, everyone. For those of you who are on the West Coast, I'm based out of Seattle, and good afternoon for those of you who are on a different time zone. So like Lori said, my name is Nate Cassou, and change my slide here. I'm an applications expert for our MSD team here at IMAGINiT Technologies. I have been in the mechanical and manufacturing engineer industry for about 6 years. I've been a machinist for about 3 or 4 years. And then based out of Seattle here, I've dealt with a lot of aerospace and military applications, pharmaceutical industry, and more aerospace, because that's what we do out here in Seattle. So today, we're going to talk about live tools with Fusion CAM. The purpose of today's webcast really isn't to be a training recording or anything to do with training. You might gain some information about some of the toolpaths we're going to be looking at, but really it's just to show the functionality of that Fusion CAM offers when it comes to turning with live tools, and really more out-of-the-box features, and really shed some light on that for those of you who do a lot of mill turn applications. So what are live tools? So live tools it can mean a couple of different things. So live tools essentially mean is it's a CNC machine that can both mill and turn, right? So we can create profiles, roughing and finishing profiles of our part, and then we can come in with other specific tools such as milling, end mills and drills and key seat cutters, things like that, and create different features about the diameter of our turn part, right? So there are a couple different types of live tool machines, right? So we can go into a lot of machines will have what's called a B-axis. So it'll have like a head, and it will have the ability to just switch tools. And usually those are quite large machines, and they hold quite a bit of tools, and their multi-axis capability is very very free. You know, they have an X, Y, Z, and they can rotate around multiple axes. What I'm referring to for this webcast really is for those using the smaller rotational turret turn mill machines. So if I may name drop, think machines like a Doosan Puma, or even some of the Haas live tool lathes, right? So it's an actual lathe that has a rotational turret that has the ability on the turret to drive milling tools. Okay? So what this does is these tools are typically driven by internal gears off the turret, and as you can see in our photo here, look, you can see the kind of features that we're able to achieve. We're able to turn down and groove an entire part, and then put in some milled features on the outside, like wrench flats or grooves, or any kind of milling features that need to be on the outside of that turn part. Okay? And again, getting back to the B-axis type heads, you know, that's more of a single head that has the ability to tilt and turn and switch tools with the automatic tool changer, and and really only has a single head. I'm mostly going to be referring to in this webcast to, once again, mill turn CNCs that have the ability to have that have a turret, right? And those live tools mounted on a turret. Okay, so what type of tool operations or live tool operations we can achieve? So again, if our tools are about our turret, right? They're, typically we'll have a turret that can rotate, maybe hold 20 to 24 tools on either side. A lot of these smaller live tool lathes will have what's called a Y-axis. Okay, so if you already know about lathes, we have our normal X and Z axis that the tool will profile a part around. And a lot of lathes will also have an indexable C-axis. So what that means is the part can lock about the Z-axis, which is also known as the C-axis, and rotate about the Z-axis, and we're able to get an arrayed feature, right? Just think of flange with a bunch of holes about it, right? So a lot of live tool lathes have that ability, but they don't have the Y-axis. So be thinking that if you really want to get more ability with some of your more complex operations about a turned part, such as the one in this picture here, it's best to have a Y-axis. So really, you can get a lot done just by having a smaller turn mill machine that uses a turret tool changer. And as long as you have that Y-axis, you're able to get do some pretty complex tool paths. So let's have a look at those. I'm going to go ahead and end my slideshow here, and I'm going to hop over to Fusion. So right now, I wanted to choose this part as an example, and again, I'm going to try to not be as teachy or try to educate as much. Really, I wanted to showcase some of these tool paths. So right now, what I have, if you ever worked with Fusion, we're always going to program off of our model, and we have the really neat ability to go into our database here that comes with Fusion under CAM samples, and we're able to add work holding. So if I go into work holding here, now again, this is included with Fusion when you purchase it, right? All of these CAM samples and work holding. So I was able to grab just a generic 3-jaw vise, or chuck rather, and extend out our jaws to fit our stock. Okay, so what I'm gonna do is I'm gonna hop over here to manufacture, and you can see that I've already got this set up. I already have my stock in here, and really what I wanted to show is the neat functionality that Fusion offers just out of the box. And if you've ever worked with Fusion before, you'll know that it does come with, or I'm sorry, it does offer our machining extensions. So everything you see here that has a plug on it, this little plug symbol, means that you have to purchase it extra, okay, with the software. It's almost like hot rodding Fusion. What I wanted to show is how we can just use Fusion out of the box, just with some of these standard features, to make this really complex part. Now, I didn't program this fully because I really wanted to focus on this boss on the side here. That's a complex feature, especially if you just have like a simpler, smaller turn mill machine that has the tools located on the turret. So let's have a look at some of these profiles. And what I also want to show you is how we can set some of these profiles up, how we would tilt and turn our tool axis, and then also how we can post this out, and depending on our post, it will show us the different the M codes to open the jaws, to close the jaws, and to also switch between your main spindle, your live tools, and your sub spindle, right? And then I'd also like to go into our sub spindle grab, our part off, and our sub spindle return. Okay. So really quickly, I'll just go through here. I've done a facing operation. Another thing that's really neat about Fusion is that we can get almost like a live simulation right here. So as we click through these operations, you'll know how it updates. So I have my face, I have my rough profile, I have another rough profile, just trying to get that material down to that boss. Okay, I've got a finishing profile. I've got a groove. Okay, so what I've done here with this groove is I've gone in here and just nibbled all that material out so I can isolate this material around the boss. And then I have this 2D contour. So this is another thing that I want to talk about. When we're just using a lot of these out of the box features or operations with Fusion, we can use the design portion of our the design environment of Fusion, and we can get some pretty nice toolpaths. So if you look at this is just a simple contour that I've used to isolate this boss. Okay, so I know that I want to clear all this material around and isolate this boss. So what I've done is I've gone into my design tab, right? And I'll go ahead and show my sketches. And what I've done is I've simply sketched an arc right there, right on the end of that, part. And I'm able to grab that sketch, that arc as my contour toolpath. Okay, so when I go back to my manufacturer, I can go into my contour, I can open this up, and I can look at this. I can go into my contour mode here, and this is the sketch that I selected. Okay, and then I can go into my multiple passes, and I can decide what my lead in, lead outs are, if I want multiple roughing passes, what kind of compensation I want. Okay, all of these features to fine tune my toolpath. Okay, so along with that, I'll jump down to another contour, which is let's just jump down to this one right here. Okay, so you'll notice what I've done here. I'll just go ahead and step through this again. So I've isolated that boss. I've reoriented my tool. Again, this is when we're using our live tools, right? So right now I've got a live tool mounted in the Z direction on my turret, which allows us to get that nice contour and isolate that boss. And then I've got a live tool mounted normal to the diameter of my part, and I'm able to start whittling material away from that boss and getting it down to that final shape. Okay, and then I'm able to come down here to this toolpath. Now you'll notice what I've done here is I'm assuming that my machine has the capabilities of Y-axis. So again, for those of you who are really looking to maximize the use of Fusion just with some of these basic tools, and you have a machine that supports that has a Y-axis, including the C-axis and your normal X and Z. This is the kind of toolpath you can get with this. Okay, and once again, I used a sketch to isolate to contain the toolpath, right? So that kind of gives you an idea about what this toolpath looks like. I'll go ahead and simulate this for you. Okay, so we can kind of see what this looks like. Okay, so we can see the movement of our tools coming down, and because I have the ability to move in both X and Y and rotate about the Z, this machine automatically becomes a very brilliant multi-axis machine where I'm able to get a really nice cleanup toolpath to finish this boss out. Okay, so I'm gonna go ahead and exit my simulation. Now you may be asking yourself, like, how did I get that? Well, same process. I go into my design and I have my sketch here. So if I once again show my sketches. Okay, so if we're looking at this sketch, see that one right there. Okay, this is what I used to actually contain that toolpath. So just remember that if you want to have more functionality with some of these basic operations and to really have more ability to make a specialized toolpath and to contain the toolpath, make sure you know how to use this design tab, okay, and sketch your toolpath in. Then you can use this in our contour. So if I go up into my contour, same process. I'm able to grab that contour, and this is very important, especially when you're using live tools. Always come down here and hit Wrap Toolpath. Okay, essentially what that's saying is I want a very normal 2D contour, but wrap it around that cylinder. And what it'll do is the post processor will automatically know that this is a multi-axis toolpath. Okay, so I'm moving forward. I contour it out once again with a nice, simple, once again, very simple contoured operation here. But I wrapped it, right? I wrapped it around my profile, and then I finished it up with just a very simple 2D trace. And that's my result. Okay, once again, I'm not gonna, I didn't program this entire part out. I really wanted to, because really those other features are pretty trivial compared to this boss sticking out the side. The rest is just a, if we're just looking at this, a turn contour, and then we have some flats and a slot. Okay, those are very easily achieved by using your tool orientation and also your wrap tool paths as well, and just some of these basic tool paths. Okay. All right. So last thing I want to touch on here is this sub-spindle grab. Now, this isn't simulated, so what I'll do is I will go ahead and show my secondary spindle. I just have this set up as a model. Okay, so I'll go ahead and show that. Okay, here's my secondary spindle. This is what it would look like if it was grabbing it. Now can get pretty complex, especially again for those of you with the smaller turn mill machines like a Doosan Puma or one of the Haas live tool machines. We have to, if there is complex features on the outside of this part, we need to make sure that it can grab it in the right spot. Now, normally what I would do is I would mill a set of soft jaws to stick in this vise and clamp around it. But you can see that what we have to do is if we have a bunch of features on the outside, we have to get it to avoid it, right? We have to get this feature to avoid hitting the chuck. So when we make our spindle grab, so if I come down here to my sub spindle grab, again, it's found right up here in our turning operations. Okay, we have this spindle grab, because what I want to do is once I finish this part, I want to grab onto it, and then I want to part it off. Okay, but I also need to make sure that this chuck avoids hitting this boss sticking out here. And we do that by a couple of different methods. We can either clock our spindles. I can either have this clocked at a certain increment of degrees to avoid this boss on the outside, and I can have both of these spindles just locked and then come in and clamp this. Or I can also synchronize both spindles. Okay, so I'm going to go ahead and open up my sub spindle grab, and I'll just kind of take you through how to do this. So I've got now again, this isn't simulated. These are just models that I've put in here. The sub spindle grab and the part, some of the part handling, it won't simulate, but it will show up in your code. So this first line here is going to be where I want my chuck to stop. Obviously, I would need something a lot deeper, right? I have to have this part go sink all the way through, but this is probably where I would want to chuck it, or maybe even closer, just to give myself a lot more strength when I'm trying to complete these back features. Now, and again, I probably wouldn't grab it from this backside because this is pretty thin material. You run the risk of crushing this on the outside, and you just really want a rigid hold. So there lies the problem of some of the turn mill operations. How do I machine this? And well, I'd probably machine all this complex stuff on this side, and then I would clamp it on that side as well. Okay, so this first line here is how deep I want this chuck to go as it's clamping onto my part. And again, the model's not going to do it because, again, we can't simulate it yet anyway. And then this line right here is where it starts feeding in. So if we're looking at our spindle over here, I have my main spindle on the left, my sub spindle on the right. This chuck will come in at a specific rapid feed rate. Usually you want to turn that down, and then it'll come right up to this line. And I can drag that a little. I can drag that a little farther away if I want to be safe. Okay, I can define the feed rate as it's moving into position before it grabs. So this is your feed rate. I can also stop the spindle, right? And then I can clock it at a certain degree if I want to avoid some of the outside features. So I'll go ahead and uncheck that. So what I really want to do though is just probably synchronize these two. So if I leave that unchecked, what this will do is it will synchronize with my main spindle. The sub spindle will synchronize with my main spindle, because if we know that we had our part over here that avoided the boss when we clamped onto it, this will sync up with it and avoid that boss as well. Okay. We can also have a dwell period that we can add to our sub spindle code. Okay. And then we also have the ability to have a parts catcher right here, which we're not going to use because we have some material on the back, right? Okay, so that's our sub spindle grab. That's where we are grabbing onto the part from our main spindle. So once we grab that, right, once it's grabbed, then I want to part off. Okay, so this is, if we look down here, these last three operations, we need to make sure that these are ordered properly. We want to grab our part from our main spindle. We want to part off. Okay, so just have a simple part off operation here. And then I want a sub spindle return. So I'm going to go ahead and open up my part off tool. This is just a simple grooving tool, or a part off tool rather. Right, and it's pretty simple. I can just come in here and it knows that I want to go all the way down to center, but then I'm also going to add in a little bit of material on the outside to face off to make that flush. Okay. Okay, and you'll notice that here in our passes, we can say that we want to make sure we're hitting transfer stock. What that's going to do is that's going to tell our part off that yes, we are coming in and doing a sub spindle grab and parting off. Okay, and I can say okay. And then that way it'll all be set up for our sub spindle return, which is our next operation right here. This is our sub spindle return. Okay, go edit. And again, this is quite simple. We don't simulate this either, but it will show up in our code. It gives us the feed rate. So once we grab it, we can have the feed rate as it's going back to this line right here. Again, this is our feed plane offset. So what it's going to do is as it's grabbing and pulling that part away from our main spindle, whatever feed rate we put in here, it's going to stop at that red line and then wrap it back into the sub spindle home position. And then we can start machining our features on the other side. Okay, so it's just that simple. Okay, so we'll say okay to that. So once I have these operations, I'm going to go ahead and hide my chuck here. I'm also going to hide my sketches. We can post-process. So post-processing, I simply come in here, go to post-process. Now, for those of you who are using a live tool lathe, once again, reiterating, we're talking about live tools, about a turret. We have, I've just chosen a very, very familiar and popular machine here. I've got this Doosan mill turn with a FANUC controller. Give it a program name. And then over here in our post properties under configuration, this is where I can tell, I can configure the machine and the post. Okay, this is where I can tell the post that yes, this machine has a y-axis, and so go ahead and output y-axis for some of those parts on the outside, some of those more complex features on the outside. Okay, I can tell if it has multiple turrets, turn on our chip conveyor, Does it have a secondary spindle? And the neat thing about these post properties is they're always updating these. And in the past, you'd have to go in and change these in the post, but they're really trying to do a lot to give you the power to add that functionality right here in the post and change some of these settings. Okay, does it have a tailstock? I can open my preferences. Okay? And if typically your live tool lathe will have a C-axis, so we can optimize operations for our C-axis. Okay, and just go through here and tell what we want to output and what we don't. Down here, use P codes for spindle selection. Yes. Position in Y for axial drilling. We can check that if we don't want to use our C-axis. Okay. Or axial drilling, we can do both. We can do both C and Y. Okay? It just depends on what our preference is. Okay, so I'm going to go ahead and hit post. I'll say yes. It processes all of these operations, and there's my code. We can go up. We can look at some of the code. We've got our P number here. This indicates that we are on the main spindle. Right, and then as we go down, it's still on the main spindle. And then as we get into our live tools, we should see a switch to P12, right? So there we go, we switched to P12, we're on P12, and then you can see right here that this is our contour, that we're isolating that boss. So we can see some of our C-axis movements, our feed rates, okay? And we can see how this is gonna output. P12 means we are using our live tools, okay? And then continuing down here at the very bottom, we've got our code and different ops for our subspindle. And so that we can go in here, we can see these M codes that lock and unlock our clamps. Another thing I wanted to touch on with Fusion is our tool library, how we can manipulate some of these tools. If we go to my tool library, I've got all my tools here. If my live tool machine, my turn mill machine, supports 2 turrets, right? I can come in here and I can refine these tools to have a different turret number. So if I go in here to my flat end mill, I can go to post process. I've got my tool number, my length offset, and this is my turret offset. So this could be used for a lot of different things. Some turn mill machines, like specifically some Mazaks, will have some smaller Mazak turn mills will have 2 turrets. Now, this isn't the kind of turret that, like an upper and a lower turret. It's just a left-hand turret and a right-hand turret, right, for doing parts on your main and parts on your sub. Okay. And then some live tool machines will just have 1 turret, but then have tools mounted on either side of it. So this is where you can give it a turret number, and this will output a specific turret number. So say we've got like tool number 3 in the number 3 position, but maybe it's on a different turret number. Okay, so this is where we can change that. This turret number can also be used for a lot of different things in the post processor. If you want to output, if there needs to be some sort of number or offset, this turret value here is great for those kind of variables. Okay, so if we ever need to change our turret number or any one of these different tool numbers or diameter offsets, we can go right here. Another thing to make sure of when we are using live tools is to always have this checked. Okay, so we go into our tool, we want to make sure that we have our live tool option checked, and it's that easy. Okay. One last thing I'd like to touch on that will really help us when we are creating tools for live tools is, remember, I can go into any one of these tools. I'll just go back into our setup here, go to our flat end mill. If I go to cutting data, be mindful of this cutting data and presets on the left-hand side. So let's say I want to use this same tool. Let's just say it's a 4-flute 15 millimeter carbide flat end mill. I can adjust my feeds and speeds and feed rates for different materials. Okay, so I can just hit plus. Maybe I've got one for 316 stainless steel, right? And so I enter in whatever that might be. Okay, maybe a feed per tooth, something like that. Maybe I can add another one for 6061 aluminum. Okay. So the neat thing is about these presets is that when I go to create my tools, I can, or when I go to create my operations, I can access these presets. So I'll say accept. And what they'll do is they'll save your feeds and speeds for those particular types of materials. Okay. So I'll say accept. I'll say close. Now I can go into my contour here. Right. It actually uses this tool and this contour, and I can drop down this preset, and you'll notice that what I can do, I can switch between these different materials now. Okay. Yeah. So, and then what we can also do now, we haven't, unfortunately, Fusion right now doesn't have the ability to do machine simulation with turning. Hopefully, they'll have that in the future. But then we can go ahead and do a simulate. Okay. I'll show my stock. We can just kind of see how this runs, just to kind of give you an idea about the kind of toolpaths we can accomplish, again, just right out of the box, just using these methods. Okay, there's my groover. I contour this out, again, trying to contain that toolpath with a sketch. Go ahead and turn my toolpaths off. And there we go, we parted off. Had a little crash here, but that can be fixed. And then I can zoom in here and you can really look at the detail on how much material I might need to take off. Okay. One last thing to note is that you can look at your machining time a couple of different ways. Go to my statistics, look at my total machining time. It's a little over, it's 11.5 minutes. You can also look at it down here. So your setup, if I just go ahead and look at my setup, your machining time is right down here. Okay. All right, so thank you for joining me. This was just a little webcast to, again, shed some light on some of these basic live tool operations and how Fusions can do some of this stuff. Fusion's a very cost-effective CAD and CAM platform, and it's I just wanted to take this time to show you that it does have quite a bit of functionality when it comes to these more complex turn mill type toolpaths. For those of you with, again, those smaller CNC live tool lathes that have the turret mounted live tools, you can really get some beautiful looking parts out of them. So thank you for joining me.